For question number 27, it's given that under root 1 minus x squared plus under root 1 minus y squared is equal to a into x minus y. We have to prove that dy by dx is this. So this is question number 27, part A. And let's write down what is given to us. So I'm going to let's write down this is 1 minus x squared plus under root 1 minus y squared is equal to a into x minus y. Okay, so this seems like 1 minus, because we know that we have this identity sine squared theta plus cos squared theta is equal to 1. And if we assume x to be any of these sine square or cos square theta, we can get this out of the root. So I'm going to assume, let's say x is equal to, let's say x is sine theta. And I'm going to assume y. So y is, let's say, sine of y. Now if x is equal to sine theta, that means that theta is equal to sine inverse x and phi is equal to sine inverse y. Okay, let's replace the value in this equation for x and y. So this becomes 1 minus sine squared theta plus under root 1 minus sine squared phi a into sine theta minus sine of phi. Okay, now 1 minus sine squared theta is cos squared theta under root, and this is sine squared phi, which is cos squared phi is equal to a into sine theta minus sine phi. Okay, this square gets cancelled with square root. So this is now cos of a plus b, and this is of the form sine of a minus b. So I'm going to use the formula cos of a plus b. So cos of a plus b is 2 times cos of a plus b by 2. So this is 2 times cos of a plus b by 2 into, the formula is cos of a plus b by 2 and cos of a minus b by 2. So this is not sine, this is actually cos. So cos of a minus b by 2. So I'm going to use this formula here. And for this, I'm going to use sine of a minus b. So sine of a minus b is given by 2 cos of a plus a minus b by 2. So the formula is 2 cos of a plus b by 2. So this is a plus b by 2 into sine of a minus b by 2. So this is sine of a minus b by 2. Okay, let's use the formula in this. So cos theta. So cos of a plus b is 2. A is theta and b is phi. So this is theta plus phi by 2 into cos of theta minus phi by 2 is equal to a. And this is 2 into, once again, cos of a plus b by 2 into sine of a minus b by 2. Okay, now this gets cancelled and the 2 gets cancelled with 2. So finally we are left with, this is cos of theta minus pi by 2 is equal to a into sine of theta minus pi by 2. So or shifting this to this side gives us cot. So this is cot of theta minus pi by 2 is equal to a. All right, which gives me theta minus pi by 2 is equal to cot inverse a, and I can write theta minus phi is equal to 2 cot inverse a. So let's differentiate this, or let's replace the value. So theta is sine inverse x, phi is sine inverse y. to cot inverse A. So we have got these values from the first step where we have assumed x is equal to sine theta and y is equal to sine phi. So theta and phi. We have replaced the values or substituted the values and differentiating this with respect to x we get. So differentiation of sine inverse x is 1 upon root of 1 minus x squared. Similarly, the differentiation of sine inverse y will be under root 1 minus y squared. And differentiation of y would be dy by dx. And this is the differentiation of, so differentiation of 2 into cot inverse A. Now 2 is constant and cot inverse A. This is also constant, so this is constant and differentiation of constant is 0. So finally we are left with under root 1 minus x squared minus 1 upon under root 1 minus y squared into dy by dx is equal to 0. Let's change the signs and try to get dy by dx. So this is, let's shift this to this side, to the right hand side. So this under root 1 minus and minus gets cancelled. So finally we have dy upon dx is equal to under root 1 minus y square on under root 1 minus x squared. And we know that under root a by under root b is equal to under root a by b. So this is equal to under root 1 minus y squared upon 1 minus x squared. And this was what was asked to prove. So dy by dx is equal to under root 1 minus y squared or 1 minus x squared. Moving on to part B.